Welcome again for this new streaming. Today we'll talk about a new technical framework. Let's say that this game framework I've been working on the past weeks, uh, related to a way to debug, to inspect, to actually edit, modify your games in a live manner. But first, I will try to explain you first exactly what I was trying to achieve when I get started with this new technology. So I will open up a window and try to explain you in details. So wait a second. Here. I should like prepare that. It's not. Okay. And here we go. Okay. Just to tell you exactly how the reason I got started with this new framework. So, in my opinion, there is a little different approach when you start to make games. The first approach, maybe the one you're most familiar with, is I need black. Is a IDE centric thing. IDE centric. Oh, it's really hard to write with a tablet. So I will clear. Paint again. I'm trying something new and I'm not used to writing with this. Oh, here. Okay, I'll rewrite bigger. ID, black, ID. So the first thing is a IDE-centric workflow, which means you have one big IDE, for instance, Unity or Unreal, and then inside the IDE, so inside the window, you have your game assets here. You have here like some properties that you can edit live, and then you can eventually, so you have a lot of UI going on there, and you have your game window here, and then you can click on the objects and edit its properties. You can modify, and you get to preview things how they will be in the game. This is familiar with in Unity 3D or Unreal. You get this kind of workflow. Actually, my pencil is too big. That's why I get so much stroke. So if you actually this is pretty good when you want to make games, for instance, static games. So when you have for instance a game when you have different levels that you have level 1, level 2, level 3, etc. So you can actually have this level showing here. You can edit it, modify its properties, place things in the level, etc. And in that case, that's a very good workflow because you get to edit directly your level and all your gameplay data. But I think it's become very hard when you get, for instance, starting to have more dynamic levels. For instance, if you have a map, generator, for instance, that will generate your level. So you get like a lot of things being generated from the map. Then suddenly it starts being quite difficult to edit things because the things you need to edit, for instance, are actually the properties of your generator that will get translated to your level. Because every time if you start modifying this level with your editor, of course, when you modify things, and if you generate a new map, all your changes are lost. So I think it's sometimes quite hard to have this IDE-centric approach, whatever the game you're making. Also, I tend to use a lot of different tools when I make my games, and I like to build some kind of specific tools for my game. And when you have IDE-centric approach, I feel that sometimes it's very good for a lot of things, for a lot of workflows. But sometimes it's not the best workflow for every kind of game. And sometimes you would prefer to have a more like direct, small editor for your particular game. And and it's not always easy to integrate this into the more global editor. So I tend to have a more like Unix approach to games development, which is you have a set of tools, you have different tools here, and you can combine them the way you want in order to build your games using the best approach which correspond to your game, to your team, to your workflow. I think it's hard to have one solution for everything. It's definitely not possible. And having this kind of this ability to use different tools and combine them together to make your game, I think is a great workflow. But okay, the problem is that you're losing, when you're doing this, you're losing the ability to actually edit your game, to inspect the values, to be able to interact with your game in a live fashion. So I was thinking it would be great to have this workflow, to have, for instance, an ability to combine tools and build a game without having something which starts with an IDE, but at the same time be able to modify here the game properties, and eventually save the change in some place. So, and this is what the inspector is doing. I call it inspector. Right now, his name is inspector. This is because it's meant both to inspect, but it can be used for much more things, as you will see. It's a new technology that you can like put into any game framework. It's entirely based on Haxe. And well, I've explained how it works now. So I will erase this part. Oh, it's transparent. I should have make some thing here. Okay, I will keep on the thing on the left. Okay, just checking. Okay, now it's not an April Fool joke. So here you have your workflow, your different tools which are used to build your game, and here you have the inspector, which is allows to access your game thing, and which can actually save things about your game, like such as, you know, like all the things you need to. Oh, that's what did I do? I have a sketchy pad now. Okay, this is a save. Save. Okay. And so the problem you have when you start building something such as the inspector here is that you will get actually trouble, because the inspector needs to access your game, but you don't have any some kind of knowledge of what the game is made of. When you have an IDE-centric approach, the IDE produces the game, so the IDE can insert a lot of data about your game. It can tell a lot about, it can put into the game a lot of information. Actually, he owns the game sometimes. The IDE owns the game, so he knows everything about the game, and this way he can actually modify the game in live fashion. But your inspector here doesn't know anything about the game. So my first choice was to not actually make the inspector into a separate thing, but to somehow integrate the game into the inspector into the game. So the idea is that you have an inspector that is compiled into your game, and you still get to access to be able to edit the thing. So here you have an UI for the inspector. So you have the logic of the inspector is entirely into the game, which enables it to access all the game data. It's not outside of the game. But then if you start if you want to also have a UI, you need a UM framework in your game, and then it's not cross-platform anymore, and it becomes very difficult to integrate custom UI in your game, etc. So instead of doing this, I choose to separate the inspector from its UI. So the thing how it works is that here you have your game, which is built with different tools. It's bundled with the inspector, and here you have a network connection between the inspector and the UI. So it's a network here, which means that the inspector will somehow send all use UI action into a separate program, which just happened to be in HTML5. Okay? So the idea is that you can actually develop your whole UI in HTML5 directly into your game without having to actually embed a browser inside your game. You will simply have, the way it works is that, I will make a zoom here. So you have your game here. You have the inspector, which is bundled into your game. Here. And so the inspector will create what I call a virtual DOM. The DOM is a document object model, which is the one basically you get with JavaScript, for instance. And you will have also a small, actually a virtual jQuery here to actually access and manipulate your DOM as you will do in any web application. Okay? So you get all the actually all the manipulation of the DOM and the jQuery. You get the CSS. You even get actually a CSS here. So you get a lot of, I mean, not all. I didn't rewrite all the jQuery and DOM thing, but you get all the attributes, the style, the events also, like click. And so you basically you have this inspector that have, and this is entirely virtual, which means there is no display, there is no, it's just data, some kind of in-memory view of your UI, of your game UI. And then here you have a client, which is an UI, which is basically a Chrome browser with this time a real DOM. And here you get synchronization over the network. Okay? So this way your game will be able to create UI for its properties, to edit, to access all its state, and it gets actually created in virtual manner here. And then when you create something here, it will send a message to the UI, which will display it here. So the UI is a separate program. So you will see that when I make a demo, you will see that the UI is not inside the game. You could actually have some technology to somehow overlay the UI on the game, but it's not yet there. So right now it's a separate application. And since I'm mostly using two-screen workflow, two-screen at work, we have usually the game running in full screen on the left screen and the UI running in full screen on the right screen, and you get to edit all your UI things, all your game things on the right. And you can see, of course, you get also like here when you get like events. For instance, if you click on a button here, or if you modify a text field or anything, if you get events that get propagated here, and you get actually events that can go from your virtual DOM then into your game. So you can add a lot of things. So this looks pretty complex, but it's actually quite simple. It's just a few classes that will actually enable you to do that. So I will do a small demo first, and then we will go into the more details of what you can do with this kind of technology. So I will just switch from mouse. Okay, just a second. Okay. I will start the application. Here, maybe there is sound. I don't want sound. I will pause. I think it's best. Okay, so here. Okay, I will show you now. This is the workflow. Okay, so here you see this is my game. It's running. This is the game I'm currently working on. It's running here. You see that there is still a lot of temporary things. And I have paused it right now because there is sound effects and we don't want to get sounds while we during the streaming, and I don't have yet a way to disable the sound. So here you have your game running, and inside you cannot see it, but it has the whole like editor, like inspector logic embed. And this is CastleDB, the tool I'm using, which is actually happen to be HTML5 application. And I have integrated into it the capacity to connect, so you can connect on this port and it will automatically create the UI that is the inspector UI. So here you have like a quite complex UI. You have all the tabs and all the panels, which is already done. And actually, and what is funny is that, for instance, if I close the application and I restart, you see that it shows the tab, and you can actually close the UI and open it again at a later time, because and even the pause is still on here. You can see I can pause and unpause, and if I close and I restart, my pause is still on because the whole state of the UI is actually into the game. It's not in CastleDB. CastleDB is just a display. So every time I click on something here, if I click here, it will send the message to the game that I click, and the game will say, oh, like populate these properties. So here we can see a few things. We have a lot of controls which are created for our games, and you can see, for instance, we can have a lot of manipulation, for instance, on the lights, on the actual ambient. If I want to modify the brightness or the contrast of the game or the saturation, you can get a lot of live control. You can even have a control on the texture. You can change the texture here and get some different values. You can modify the bloom or a lot of different things. So this is entirely done on the like by using reflection on the shadows of Ips. So this is a part which is somehow Ips specific, because Ips knows about your game scene, he knows about your shadows, and he will be able to automatically, it knows about your scene. Here you have the scene, so you have the different, the world part. He can actually do this kind of things when you can come to pick a specific model, and here you can modify its visibility, etc. So this is the part which is like IP specific in the sense that it does all this logic for you. But the actual text I'm presenting today is the fact that you can integrate this into your own game by using your own custom editor framework, and you get access to reading and saving files. And I think that's pretty nice to have this this workflow. So let's look a bit about the sources, okay, for it. I will switch camera just to make you give you some understanding of how easy it is to add more UI in your game. So I will open I will open an Haxe sample. Right now it's only integrated into Haxe, so it's opening. Okay, checking if it compiles. I need to disable that. Here, okay, I need just to check, just change a few things. Just a second. I need to edit a few properties because it doesn't compile right now. Lib castle, because we have updated something in JavaScript, and so I will just compile for Flash. Yes, yes, okay, let's try this. And yeah, it's not up to date, so I need to rewrite to update here. Just a few seconds. Do you have any question right now regarding the inspector? You can ask on the chat. I'm just synchronizing things now because I'm using old version. Okay, so here you have your an example that is part of the Haxe samples, which just run a skin thing. And here you open CastleDB and it doesn't work. Why is that? Let me check. Go back to here. Maybe something with not a bad synchronization of the tools. I try again. Yeah, I don't. It's not my main computer. I should be maybe testing everything before every streaming, but it's a bit hard. What is this? Maybe it's. What would be the reason for that? Let me check. Here it's running into here. Let me check if it's running the good version. I have that. Maybe I can. Yeah, maybe I will do that. Most likely, this is it. Here. So I check the question. I am correct to understand I can inject my own non-Haxe renderer. Yeah, you can actually integrate this inspector into any non-Haxe, any kind of OpenFL like Lime, like Snow, every tool, every game. Even if you write your own technology, as long as you use Haxe, you can actually integrate this into your game. And you can have different tools using the same technology. The only thing that you create UI into your game that gets displayed into another application in HTML5, and you can build on to build a lot of different tools. Does it watch the file system too? Well, you can modify the file. You can watch the file system in Haxe in debug mode, and so it's again, it depends on your game. If your game framework enables you to watch the file system, because the inspector is inside your logic, you could build actually some additional logic into the inspector. For instance, I have a few plugins in CastleDB that actually does under the panel, and a few, like for instance, pop-up menu, right-click pop-up menu, and so you could add more of this into your client, UI client, to handle more services for your game. It's really extensible. First, I will try to run this. Okay, That's where I stopped. I check a question again afterwards. Does it work? Still no luck. Well, I will try with the. It doesn't work with this. It used to work. Well, anyway, we'll just look at the code because I already made a demo for the game I was doing. So let's look directly at the code. Okay. So here we have. This is in the if sample. You have this if castle because right now the inspector you have all this somehow virtual DOM integrated into the castle library. I should be able to take it out, and I should actually take it out in the own library. Just if someone gets started using it, I will do that. So right now, if using castle, it means you're using inspector, and it creates this, which is a inspector for the 3D scene. And here, if we had a rotation node to the scene panel, and here you get a few properties that you get a property v that when it's you get a getter and a setter that can actually do something in your code, and you can actually add here a custom property that creates a button with some text, and when it's clicked, you create a new panel. So this is the jQuery I'm talking about, is that you can actually use things like when you're doing jQuery, even if your game is not at all in HTML5, you can run in C++. It's not problem. The wall, every time you modify something, it will be sent over the network to game UI. So here you have a few things. So if you look at the way it's structured, you have here in the heap specific part, you have a package inspector. You have the inspector itself, which is quite specific in the way, very specific. It will create the different panels that we saw, and it will, for instance, the scene panel will browse the heap scene and display all the objects. It does that by creating, HTML, and by actually using a find and add class and binding click events. And when you click, it toggles the class. So I mean that's something you will do if you create again an HTML5 application, but you're not doing an HTML5 application. You are in your game, so you can access all your game logic, all your game variables here. And here, for instance, if depending on the kind of the object, we return the icon to display on it. So you have all this for the scene, heap scene. The inspector itself will manage all the panels. It's not a lot of code. It has some code to display the texture, and yeah, doesn't do a lot of things. And you have this load and save things done. So this is still quite framework specific thing. Less framework specific thing is a property manager, which extends the CDB GQ client. So the client is actually the game, and the server is actually the UI in our model, because the games connect to the UI. So here you have it connect on the local port on this port, and use a socket. So well, here I'm using a HXDNet socket, which attract a bit the things, but you could use like a C socket without any problem, since we have it's a socket based on events. So it's not it needs to be able to, well, we could define that. I have to look this into when I take it out of heaps framework. But that's mostly the only very specific thing. So all it does is that it will take care of an history and of handling properties. So you have here different kind of properties. You can have a boolean, an integer, a float, something with a range, a string, an enum, a color, a group, a texture. So the texture is a bit heap specific here, you can see, and the color also is a vector. But apart from this, you get everything is pure data. And here, so for instance, when you have all these properties that are editable with this tool, which could be customized. So it creates again, it just handles the UI for it. And as you saw in the previous example, maybe it will work again if we restart it. because it seems to be coming from my here. Here, yeah. So here, when we start the game, it will create all these properties, and when you click on something, this is a property that gets edited there. So you get this, for instance, this is a range property, which range from -1 to +1, the brightness, and you can actually modify it, and when you modify it, gets a callback, which actually impacts your game in real time. And I guess that's about it. So is there any question for it? Is socket based? Yeah, the inspector is socket based in the sense that it's connect on the UI using a socket. So you need to be able to connect to a socket. Right now it's only using TCP, but I guess if you have, for instance, HTML5 application, you could either like embed the server directly into HTML5 application and have the UI running, or you could actually have a third-party application and connect to WebSocket. There's a lot of different ways of doing that. It's still very quite early technology. I plan to continue improve it for IPS. So if you want to use it for your own framework, it's quite easy to integrate. So have a look. The parts you need to look at are in Castle Library. You have the client, which is this is entirely cross-platform. All the CDB parts is just really cross-platform. It doesn't have to do any kind of thing. So here it does this is a client, so this is your game. It have it handles all the mapping of the DOMs, and you have this virtual DOM here, which has a node name, node value, new children, and all the attributes, and you have all these things. So for instance, when you modify the attribute class, it will also update the list of the class, etc. And then you have event, which is an event that gets sent by the client to your, or by the server to your client. And you have jQuery here, which is an implementation, a part of jQuery. So you have as class, add class, text, HTML, the click events, bind, unbind, so find children, append to, insert after. So you have a few of the jQuery APIs, not all of it. It's still a few, and I am adding it little by little, trying to stay compatible with those things you do on the web fashion. And here, this is a message that gets exchanged between the games that the game UI send to the display. So you have a create, add class, remove class. So basically, when you change your UI, it will send to the UI service this message to update it. And then you have like the server, which is this which is the server. So this one needs to be in JavaScript, run into JavaScript, and which will receive the message here from the client and actually do this. It will create the elements, modify the list. So it will do the actual change into the real DOM. It will propagate the change from the virtual DOM to the real DOM. And it's actually very efficient. As you see, that it doesn't make any performance difference, even with actually quite big UI and a lot of here in my game. I have a few thousands of UI elements actually. I have a big scene here. You can see here a lot of elements, and even a startup is really fast to send all the data and to actually be able to edit it. And you don't see any difference if it's another process or not. Well, if you do, like, if you want to see, for instance, some kind of texture here, you will get sometimes a bit of delay, especially for the big one. If I want to click on a depth map texture here and I want to check in RGB, here you get, of course, you will get some delay, the time, but it's more the time that it is spent to encoding the texture and displaying, because in HTML5 then the time is actually spent on the thing. So it's very responsive UI. You get and still you can, yeah, I think that's a very nice approach to have a very, and of course you can style this in CSS very easily. So I think it's a very good approach to UI without having to write your game actually in HTML5, which sometimes is not possible if you want to do like quite complex 3D things, or even if you want to use an OpenFL, I mean, or for different other like runtimes. And that's about it. I hope maybe you will have more questions about it. I will try to answer when possible. Don't hesitate to put your questions on the chat or at the bottom of this video. Thank you for coming here, and have a nice day. Bye bye. Oh, when do I release it? Oh, right now it's, I have a few questions actually. I will check on the question first. Right now, it's not released in the sense that it's not yet entirely out of Castle. I think it's better to keep it that way for now. So you can actually use all the like client and server that I show you there directly. You will have already into Castle, you have already a server implementation, which is called, it's not here, it's in the Castle source. This is just the Castle library. So you can actually, I think it's good to start using it first within Castle. Each open a new tab in Castle, and you can have this here. And then of course you can, this is just a if specific things, so you don't have we don't have maybe to take them out. You might want to reuse the same things I'm doing, such as the panel and a few other things, but they are still done into a quite, well, this is platform agnostic. It doesn't have to be tied to it. It just references the inspector. So yeah, I'm not sure yet if we want to have one common inspector for all the games, some kind of abstraction of it, and what will go into. Maybe it's better to have one inspector implementation per game framework, and then still have this same technology for so the wall here, the CDBGQ package for just handling all the like UI display. And so yeah, it's released as part of CastleDB, and I plan on contributing more and adding more things into it as we go. So don't seem to be other questions. Okay, so I think we are already done now. Bye bye.